Yeah, I'll react to that, sure. All right. Hey guys, I've asked this question a few times and I've had it answered a few times, but I still wanted to see a real, full video of just how this stuff works. My original confusion was how a a obviously I know that pointing down your thrust will move upward, but I was always so baffled by how having that thrust in the very back of the plane wouldn't just cause the plane to do this. All right, so here's the thrust. Here's the. I gotta kind of look at myself while I'm doing this. Here's the back of the plane, and then having the thrust. I'm surprised it doesn't just do this, And so I'd like to watch just a full video explaining this. Let's do it. Preemptive flight, the real life sci-fi of vertical takeoff planes, real engineering. Great channel. Let's go.
Website that helps you think like an engineer. The sight of a 9.4-ton plane slowly rise off the ground, balancing precariously on 4 columns of air over the rough water of Galway Bay, is the closest to sci-fi alien technology I have ever seen in my life. An inspiring sight that seeded an obsession with aviation technology. The Harrier was the culmination of decades of bizarre experimentation to eliminate the plane's greatest weakness, its need for a runway to both land and take off. This fascinating technology has one of the richest histories in aviation, with roots in both the lunar lander and...
Sorry, guys. All right.
Fascinating technology has one of the richest histories in aviation, with roots in both the lunar lander and outlandish World War II era German sketches. Both the Allies and the Germans used helicopters and autogyros during this period, but using a rotor for both lift and thrust inherently trades off speed. The Germans dreamed of a plane capable of taking off from anywhere, eliminating the need for tactically vulnerable airstrips without sacrificing speed or dogfight capabilities. Inspired by their ballistic missile program, which still lacked effective guidance programs to accurately target Allied aircraft, Eric Bauckham developed the tail-sitting, rocket-powered BP-349, which would allow the pilot to take control of the plane in its final stages of flight to guide it to its target and unleash a barrage of smaller rockets before ejecting to safety. The only manned test of this aircraft resulted in the death of the test pilot, and the idea was abandoned, but that didn't stop the Germans in their pursuit of vtol aircraft. Next up was an even more bizarre tail-sitting aircraft that featured 3 propeller blades, each powered by ramjets at their tips. This would function similar to a helicopter for takeoff and then transition to forward flight and use the blades like a giant propeller. But it would require a nose-up position to achieve adequate lift, as it didn't have any wings. Unsurprisingly, this didn't make it past basic wind tunnel testing, but could well have inspired the Lockheed XFV and Convair XFV Pogo planes in the 1950s, which used massive counter-rotating turbo propellers.
As horrific as the world wars are, or wars are in general, I often see comments of like, imagine, how do we have technology today? And a lot of responses like world wars, right? And it seems that's kind of correct. Is that imagine that you didn't have World War I or World War II, especially imagine not having either. In World War II, you wouldn't have the drive for giant subsidization into these types of projects, and then therefore you wouldn't have the rocket engine, and therefore you wouldn't have the space race, and therefore you wouldn't have satellites, right? And then think about how much of our technology today relies on satellites, and if that stuff didn't just pop out of nowhere, it happened because of the drive of military weapons, right? And so as scary as it is and horrific, it is crazy to think about how much of our non-wartime technology depended on wartime technological development,
Pogo planes in the 1950s,
oh my God, that's
which
crazy.
used massive counter-rotating turbo propeller XFV Pogo planes in the 1950s, which used massive counter-rotating turbo propellers. The Lockheed version only ever managed to hover for a brief moment while transitioning from a horizontal flight to an upwards vertical flight, but the Convair XFV Pogo, flown by Lieutenant Colonel James Coleman, became the first aircraft in history to successfully fly in both forward aerodynamic flight and in hover. Ultimately, both planes were cancelled due to the difficulty in flying them and their lack of speed and lack of lifting power. Engines for propeller-driven aircraft were simply not powerful enough yet. To achieve necessary lift, the rotors would need to increase velocity or diameter, which would decrease the max horizontal speed of the aircraft, as the tip speeds of the blades would rise, meaning the tips of the blades could easily break the sound barrier. and cause all kinds of problems. This problem and how the incredibly versatile Osprey solved it needs a video by itself to explain the nuanced design of helicopters and their speed limits, but for now you'll just have to trust me that it's a difficult problem to solve. Yeah. And with the advent of powerful jet engines, the problem was largely solved without the need for large propellers. The first aircraft to use jet propulsion for vertical takeoff was the Rolls-Royce thrust measuring rig, aptly nicknamed the Flying Bedstead, for its obvious departure from the bird-like designs of the past. This configuration largely influenced the design of the lunar lander training vehicle that NASA developed for Neil Armstrong and other astronauts to practice with. They mounted the engine on a large gimbal to ensure that thrust always pointed directly downwards and only provided enough lift to simulate the moon's gravity, while hydrogen peroxide rockets were used for control. Neil Armstrong attributed the success of his difficult landing on the moon to this ingenious training vehicle.
Hydrogen peroxide rockets? As in that stuff that I can literally swish in my mouth to clean my mouth? Same thing? Hydrogen peroxide?
Neil Armstrong attributed the success of his difficult landing on the moon to this ingenious training vehicle. The lessons learned through early research aircraft like these provided Rolls-Royce with the knowledge required to develop the Rolls-Royce Pegasus engine, which powers the Harrier. This engine needed to have enough thrust to lift the entire weight of the plane. The designers of the plane made this job easier by utilizing carbon fiber composites for much of the aircraft structure to save weight, making the Harrier one of the first planes to use these materials. Yet the job of designing a single engine capable of providing enough vertical thrust was still difficult, and the resulting engine is pretty unique as a result. The engine is similar to a traditional jet engine in that it consists of a low-pressure compressor fan, a high-pressure compressor, a combustion chamber, a high-pressure turbine, and a low-pressure turbine. Where it differs radically is the engine outlet is not just one large opening, but split into four.
Okay, so you have the combustion chamber, and then you have the turbines before and after the combustion chamber. The ones before the combustion chamber are used so that you can compress the air itself, the air in front of you, to be condensed enough to when it enters the combustion chamber, it's condensed enough to be a giant fuel source. And then the propellers after the combustion chamber are to then condense that again to lead the aircraft and therefore create thrust, right? I'm trying my best to understand this stuff. I'm not a rocket scientist.
Where it differs radically is the engine outlet is not just one large opening, but split into four.
Who?
A high-pressure compressor, a combustion chamber, a high-pressure turbine, and a low-pressure turbine. Where it differs radically is the engine outlet is not just one large opening, but split into four, where the first two nozzles duct some of the air coming from the low-pressure compressors, and the final two duct air from the higher-pressure turbines. Because the air bleeding from the low-pressure compressor...
Okay, all right. So, at first I'm asking, why have these front two, right? This seems like... So the front two provide additional lift to the wings, I'm assuming? Because if that's not the case, then why have these in the first place?
Final two duct air from the higher pressure turbines. Because the air bleeding from the...
You gotta shut up.
Opening, but split into four, where the first two nozzles duct some of the air coming from the low pressure compressors, and the final two duct air from the higher pressure turbines. Because the air bleeding from the low pressure compressor system has less force than the high pressure nozzles, the low pressure nozzles need to be placed further from the plane's center of gravity than the high pressure nozzles. This balances the plane along the length of the plane, but in vertical takeoff mode there is no air flowing over the wings to provide force for the control surfaces. So the plane needs a way of controlling its roll, pitch and yaw in vertical takeoff mode, and so the plane features nozzles that bleed air from the engine on the nose,
God dang it.
Vertical for the control surfaces. So the plane needs a way of controlling its roll, pitch and yaw in vertical takeoff mode, and so the plane features nozzles that bleed air from the engine on the nose, tail and wingtips. This control system is not as reliable as aerodynamic lift, which is...
So the reason for those is... Okay. So the reason for those first ones are to create... So the reason for these is so that you don't have all of the lift coming from this section of the aircraft, because then the yaw, which would be the way the plane is pointing. So these are actually for the thrust as much as these are. These aren't for just creating lift on the okay.
Pressure compressors, and the compressor system has less force than the high pressure nozzles. The low pressure nozzles need to be placed further from the plane's center of gravity than the high pressure nozzles. This balances the plane along the length of the plane, but in vertical takeoff mode there is no air flowing over the wings to provide force for the control surfaces. So the plane needs a way of controlling its roll, pitch and yaw in vertical takeoff mode, and so the plane features nozzles that bleed air from the engine on the nose, tail and wingtips. This control system is not as reliable as aerodynamic lift, which is largely self-correcting when disturbances occur, although fighters tend to purposely decrease stability to increase maneuverability, which requires a computer to constantly monitor. But the disturbances due to the ground effect from its own jet can cause oscillations that overwhelm this control system, and with no accurate way of correcting them, they can grow until the plane inverts and lands on the cockpit, which has killed pilots on several occasions. So pilots often drop the plane heavily from a few meters above the ground before the oscillations could take hold, which obviously wasn't ideal for the landing gear. The Harrier was also disadvantaged to conventional aircraft as the vertical takeoff mode was severely limited in max takeoff weight and burnt off much of its fuel in this intensive maneuver, reducing its range too. So most Harrier takeoffs take place only as a partial vertical takeoff, where the plane would accelerate on the runway like a conventional plane to achieve some lift from the wings and then angle the nozzles to achieve the final lift needed to safely take off.
Could you attach an additional fuel line from the carrier itself to fuel the jet aircraft taking off, and then that hose can disconnect when it transfers to horizontal takeoff? You know what I mean? So like attach a hose, maybe by some magnetic attraction, to the plane, so the hose fuels the takeoff so that it doesn't have to waste its onboard fuel on the takeoff itself. But maybe like the disconnecting of the hose itself would screw with the stability of the plane. And also you couldn't rely on a hose if you're in some non-base or non-aircraft area takeoff zone.
Achieve some lift from the wings and then angle the nozzles to achieve the final lift needed to safely take off on the shorter runways of aircraft carriers.
Right, so that works on shorter runways, but doesn't work on vertical takeoff.
The plane could then land vertically without wasting as much fuel later on when the weight of the aircraft had reduced through its use of fuel and armaments. This takes its max takeoff weight from 9.4 metric tons to 14, which is still lackluster when comparing to its fellow marine aircraft like the FA-18 Hornet, which has a max takeoff weight of 23.5 tons and a maximum speed of 1.8 Mach, compared to the Harrier's subsonic 0.9, making it a much more capable attack platform. But the Hornet is only
and in that scenario, you'd have to expend your armament, since I'm assuming the vast majority of that lessening of the weight is attributed to the armaments rather than the fuel. You know what I mean? And so if you don't expend your armaments, then you won't be able to land as well?
Capable of launching
0.9,
making it a maximum speed of 1.8 Mach, compared to the Harrier's subsonic 0.9, making it a much more capable attack platform. But the Hornet is only capable of launching from large carriers, whereas the Harrier can launch from amphibious assault ships like the USS America. The Harrier has even managed to land on a cargo ship when its pilot lost radio contact with his crew and ran out of fuel.
That's crazy.
Both of these fighters are slated to be replaced by the controversial F-35, which will be capable of VTOL, thanks to the incredible directional rear thrust and shaft-driven lift fan. This fighter improves much of the technology the Harrier laid the ground for, while including futuristic VR helmets allowing the pilot to see through their own plane, using 6 infrared cameras surrounding the plane, advanced laser targeting and radar capabilities, all the while incorporating stealth technology. The plane has been deeply entrenched in US politics, raking in huge developmental costs and supporting thousands of American jobs. It has been delayed again and again, largely due to its ambitious technological leap over its older counterparts. Should it finally reach service, it will become the most advanced plane in the history of mankind. Each advancement like this is built upon the foundations of physics that humankind has learned over the course of our existence. If you would like to flex your physics knowledge and learn more about the principles of the universe upon which these machines are built, I highly suggest you check out brilliant.org. Brilliant is a problem-solving...
I'm going to watch through this, of course, for the channel. I thought that a downward facing, obviously I'm wrong, but I would think that the downward flaps of the back would make it more likely to flip this way. Since any air pushing against... Oh, maybe not, because the air going downwards wouldn't... No. Okay.
If you would like to flex your physics knowledge and learn more about the principles of the universe upon which these machines are built, I highly suggest you check out brilliant.org. Brilliant is a problem-solving website that teaches you how to think like an engineer. You can dive in and start learning about a huge range of topics, starting from basic physics and working your way up to more complicated topics. For an example, check out their course on classical mechanics, one of the most important subjects in mechanical engineering. The first 200 people to sign up with this link will get 20% off their annual premium subscription. I get to learn and solve these kind of problems for a living, and I love it. It gives me that warm, glowy feeling inside when I finally conquer a difficult problem. Actively challenging your brain on a daily basis and getting that endorphin rush of a job well done is great for your mental health.
This is giving me PTSD from college when I thought I could go into physics, and then I realized I just can't do it. I'm not smart enough, and then I went on to history, which I'm glad I did because I find it much more enjoyable. I was just kind of going into physics because I think it'd be cool.
Brilliant even have an app where you can challenge yourself on the go. I have even been guilty of pulling out their puzzles section to challenge my friends while out for a pint. As usual, thanks for watching, and thank you to all my Patreon supporters. I just uploaded a new episode of Showmakers with special guest Grant from 3 Blue 1 Brown. The link for that is on screen now, and the links to all my social media are in the description.
Great video. I asked a lot of questions there. I find this technology fascinating. Clearly, I know very little. I'm just kind of trying to use my own kind of common sense logic to ask questions here. So some of them may sound very dumb to some of you who are more knowledgeable about this stuff, but you guys are always great with helping me figure this stuff out. So love y'all. Hope everyone's doing well. And hopefully I'll see you guys next time. We'll keep on learning. Bye.